Hello everyone, welcome back to our tutorial series where I'm explaining how you can build your agentic AI for analyzing a request for proposal to generate the technical proposal. And there are a lot of sections which we need to build a technical proposal. I have already explained in my previous video. This is what the current agentic AI is building, like executive summary, project goals and the objective, scope of work, high-level technical design. Then we have a detailed data flow. Basically, I mean, what all the solution, basically what all components you're gonna build, what is our strategy, to ensure the security and all, and then we're gonna have, the how we're gonna deploy this solution to the cloud side. And it's not only limited to that. This is completely depend upon what kind of request or proposal content is, and based on that, this agentic AI is intelligent enough to figure it out what kind of a structure needs to be built according to what the request for proposal is expected. Right. So I have already explained this in my previous video. If you haven't watched my previous video, you can watch that, because we have this first phase where we have just implemented the very first round of creation of technical proposal. Then we have deep diving in here with these four options where we can elaborate the proposed architecture, deeper comparison of the technical technology stake. Then we have a cloud deployment strategy deep down, and then we can change the technology stake as well. Right. So these are the four different options we have. Then the last one which we have is which we have implemented is related to the estimation, where we can get the the effort and the estimation and the actual price, not only for the development but as well as for the deployment on any given cloud on a monthly basis, right? And that is what you can see on this technical proposal. At the end, we have those estimation as well, which actually gives us how many percentage we need, what all resource we need, and how much it is going to cost. And these all information are coming from the MCP server, where we have this cloud pricing, a CSV, by which gets updated based on the monthly basis as of now. But we can just make it more frequent depending upon when the things are getting changed. Right. So far everything is good. The only problem with this application is, like, this agentic AI is it doesn't have its own memory, right? That is the most important concept for the agentic AI, because if you really want to make it more performant, you have to ensure that whatever the past information was processed by the agentic AI, it can get stored somewhere, and we call that as a knowledge base. So whenever the similar request come now for the next or the future RFP, which always happens in our world, then definitely it can just go to the knowledge base and figure out what kind of solutions we have given in the past and how we can utilize the similar solution here if it is applicable, right? Which is very important to have. The another problem is this agentic AI is going to solve is we get this lot of RFPs, right? And then every RFP we start from the beginning. And if we want to refer some old historic, technical proposal, we have to always go back, search the information here and there, and we have to figure out whether the expert is still available with us or not. So this is where the agentic AI with this long-term memory is going to help us, because it is going to just save the summary of the memory, summary of the RFP as well as the technical proposal, like what kind of key highlights we have in given RFP as well as on the technical proposal, right? So this is where this fourth section comes into the picture, where we have this concert agent knowledge base. Right. To implement this, what I have to do is I have to include, or I have to integrate another server, which is the memory server, memory MCP server. If you have been watching my previous videos, I have explained how we can implement that by line explanation. But still, I can quickly show you that this is how it looks like. This is what the MCP server is. First is initializing the memory. So what it needs two main libraries. I have already explained this in my previous video. If you want, you can watch that. I will provide the link in the description. You can also see on the right top of your screen as well. So we need these two library files, which is a Facebook Artificial Intelligence Semantic Search, which is the in-memory vector database. Then we have this sentence transformer, which actually provides the embedding model, because we have to convert the text into the array of the numeric values. And then since FIAS is based on NumPy, so we need a NumPy so that we can cast that numerically represented text in a vector form into the NumPy array, so that FIAS can understand now. Right, these are the two libraries which you need, which is very heavy to have, which is very heavy library. So that's the reason having a separate MCP server is the right option, and that is where this MCP protocol is helping us to decouple our logic, especially these a server can be run on those server which is very strong on a CPU perspective. And based on the MCP server, we can decide what kind of configuration we need for the individual MCP server. Right now, coming back to the logic, it's pretty much same like, I mean, I will provide the link so you can watch this where I have explained all these things in a very great detail. But just for this particular series, you can understand this is the method which we have to feed to our MCP client through the agent, depending upon what kind of requests are coming from the user from the UI. And then we have this recall, and this is the signature for that, right? So this is what the MCP server is. And then now how the flow will start from the UI. Right. So as you can see, if there is nothing, and if I just put the query manager, so if there is no request is being raised to the application, then it is going to collect all the memory, whatever it has captured so far, and it is going to give us here, and we can understand what kind of RFPs and the solutions we have, worked so far. Right. That would give you the sense also, and you don't have to go to the Google Drive or just see what kind of RFPs you have completed in the past along with the technical proposal. Right now, coming back to the API logic, this is what the API logic is. Here, what we have to do is I have to just write this simple program which says that run recall task, and this is what I'm going to call through the event handler, and this is the function for that. It requires a memory query and the memory output. So one input, one output, and this is what you can see. This is my query and this is my output, and this is my button. When we click on this, this is the event on which this particular function will be called. And this function is very straightforward. It is actually just making a connection, making a communication to the agent and asking to run this recall method with this query, which user is going to put it over here. I can ask, did we have any solution deployed on AWS in technically proposal? Please share. Right. So this is the query which I asked. Let's see what happens, and we can just come back here in the flow. So once any query comes here, it goes back, goes to the our agent, and then we can just see where is this run recall method is. So this is the run recall method, which is the new implementation which I have done, and this is again the same logic. All we need is, since it is coming here to just reference the memory, it means that it has to directly make the connection to the server, and that's the reason we are populating this MCP client related parameter like a standard IO server parameter, and then here we are just making a call to the client session, right? And once it get this server name and the query which we are creating here, query text and all, and here you can see we are just creating this command list where we are saying which server do we call used. And definitely this is the standard. We have to add this new server in our list, server to manage, right? So that it will know. And since it is not utilizing a think method for now, so that's the reason it is hard coded. So it is just calling the memory one, and it is just checking whether the information is there or not, right? And then it is returning back. It's very straightforward logic, right? Now coming back here, we can see here what response we are getting. So most relevant memories found is detailed cloud deployment service for client corp platform. The second one is including instance size comprehensive. And then we have for the CGI MNE, right? So outline proposed AWS structure. So this is the most matched information we can find out here, right? We can also ask what all customers if we have right? So we can ask this, and let's see what response we get. This is one use case where it is really solving a problem for the past process RFP or the technical proposal, but this is just a one minor advantage we're gonna get. The main advantage which we're gonna get with this is whenever we just create a new RFP, we can always utilize the memory along with the latest and the greatest technology we have, and we can also have a reconciliation to provide the more competitive and effective technical proposal, right? If you just come back here, we can quickly see this client core platform, and the another one is the KIP Foundation, and the third one is the UPS So these are the three customers for which we have this supported, we have worked upon so far, right? So this is what we are getting. So we can ask any question in a simple plain language, and it will just go to the memory server and look for that. Since it's a vector DB and we are using a FIRES, which actually provide the semantic search capability, that's the reason we are getting three most similar result from the query which we have and whatever the data or the summary we have memorized in our memory server, right? That's one. Now, the next thing is, I mean, if there is a new RFP, then how it is going to play out. That is where we have to change a little bit thing over here, because now we have to tell to our large language, or basically the agentic AI brain, like you have to memorize whatever the new, RFP you are processing, right? So that is where, this change has to be done here, where I'm saying, okay, memorize the summary. So basically I'm dictating, and we know that whenever we have a new MCP server and we have to see, we have to understand how we have to change our prompt so that the new server can be utilized for their intended purpose, right? This is one change for memorizing the summary. And then this is another change where we are saying, okay, recall the past one. And that is what it is going to happen. So in real time, same customer gave us multiple RFPs to us, and that is where this agentic AI is going to play a very important role, because it is going to extract the information, like how we have built the technical solution, what kind of information we have there. Once we get that reference, we can always go back to the technical proposal and figure out the thing. Right now, there is another future advancement which we can do is like we can reference the complete technical proposal, because right now we are just storing a summary. But that is going to consume a lot of memory, and probably that is again a future advancement which we can have into this application. But right now we are just stick to the summary part which we are storing, right? So first is try to just extract that information, like for what all company we have worked in the past, where we create a technical proposal, right? And we can just have a more intelligent summary as well, where we can capture like whether that client has accepted our proposal or not. If there are multiple rounds to happen to get selected, then how many rounds we have cleared, where we failed, and we can also save the feedback as well. What kind of feedback we got when we were not able to win the RFP. Right. So these are the two places which you have to change, and prompt engineering is really something which you have to be more creative and more innovative. Right. So that's the one change which you have. And the next thing is whenever you have any action, it's not in the initialization, because in initialization, you just create a first round of technical proposal, but in deep down, you just elaborate with the multiple options. Again, we have to utilize this memorization. So basically, whatever the new information you are saving, with any running option, you have to ensure that that is actually memorized correct, right? Again, the read context recall as well. Again, you can see here we are again trying to just recall. We just ensure that whenever there is a deep dive option for any given like elaborating technical architecture or deep downing a comparison of the cloud deployment strategy or the technology state comparison, whatever it is always need to recall from the past as well to make that more informed decision. Right. So this is again, very important thing to happen, and this is how I implemented that. I know the code is now getting more complicated, and as we are going to add more and more, server, definitely this prompt is going to be more complicated. Logic is going to be more complicated, but this is how it works, and that is where we have to refactor the code, and we have to make this code more decoupled so that we can easily maintain it. Though MCP protocol is really helping me in that sense, just imagine if you don't have this MCP protocol, then how complicated this entire agentic AI is going to be, right? So that's pretty much it from the code perspective. Now we can just run some more intelligent, query. I have already explained this is how it works. So now we have 4 steps. One is the initial analysis of RFP, then we have a deep down option, then we can generate the estimation effort and the costing. Not only the costing covers not only the development cost for the solution, but as well as for the deployment strategy, along with how much cost it will incur on a monthly basis for the various clouds. Then the last one is to just have the knowledge base generated, and that is where this memory base MCP server will come into the picture. Whenever you make any new RFP created, always, there would be a new summary will get added, right? So this is the new RFP which I have put together. I can just add another one if I want to. So let's quickly try to run the new one, your environment. We can quickly use this RFP and try to do this, right? So I'm just gonna pause this because it is going to take a little bit of time, and I don't want to make this video long. So let me just pause that, and once this is done, then I'll just resume to the video. Okay, so it is still working, and it's going to take a little bit of more time. So let's quickly check. Yeah, it's working because it's progressing. It's making first it just goes to the recall to the memory, which is good. First, it reads the content, then it goes to the recalling method of a memory server, which is good because it has to reconcile against the previous data which we have saved. Then now it is making a request to the web search, which is again a very important things to happen. And now we can just see some past requests which I have already completed. And this is how you can see the first version where we have the initial version, then we have 4 options which I have done. Then this is the estimation which I have done. Right, so there are a lot of customers which I have processed so far, and once this request is done, then we're gonna see another one here. So let's see if it is done or not. It's still taking some time, though we cannot see any difference in these RFPs which are getting generated, because even if I just open this one RFP dashboard which was for CGI. Right, if I just go down, the only thing is what you can observe is you can always compare, once you add a new MCP server, you can always compare that with the previous version. That's the easiest way to compare, what kind of additional information you are getting. But you can dictate that part as well, but I haven't think about that because I just wanted to have all the important MCP server integrated. And once I reach to the point where I observe that okay, now I have covered all the aspects which is required to respond for any RFP from the proposal perspective, then probably we can just keep adding a more depth to each and every server to make it ready. Even without the manual intervention, we can have a very solid proposal which is already in shape, but we can just make it more concise, more precise, and more accurate, which requires a less number of review sites, right? So it's the first part is done. Right, so now we have this another customer, which is the new customer. I haven't heard about him. It's this Moreland County Community College. We can quickly run the memory and see if we get the something related to this one. Let's completely check on the server side as well whether along with the recall the memorize thing has been done or not. Now we can see it goes for the web search, file system, creating a markdown, converting into the PDF, right? And PDF is creation, and this is the important part, and that actually ensure that now it is actually memorizing proposed dual enroll pro. So basically it is capturing the solution name and the cloud native SaaS solution for the Westmoreland County Community College dual enrollment management. So it seems like it is able to do that, and we can quickly see that this has to be bigger. So it is. This is the part where we can see the sample. We can ask this question whatever we want. Have we ever worked on and we can quickly check that, right? So let's quickly see. Have you ever worked on this? Now we can see this query just in here. And we can quickly check that. Okay, now we can see proposed dual enrollment, which is good. Right, so this is the very first memory summary which we get. So this will give us a sense that we have already worked on that, and we can always go back. And this information can be enhanced furthermore to make it more user friendly. As I mentioned, we can add a lot of more information if you want to with the summary, because right now the summary is very concise. I can just make it more lengthier. Let's say I think 5-6 line, where we can have a 1 line for every section which we have here, right? So for example, what all headings we have executive summary, proposed high level architecture, understanding the challenges, meeting problems. So we can have a one liner for all these main headings, and that we can add it here. And then as right now, if I just see how many records we are returning for the recall, it's 3. We can just make it based on whatever the sections we have. If we have 10, probably we can just create a 10-line summary. And here we can just report the 10. I mean, this completely up to your logic. I mean, what exactly or precisely you need to get, so that it would be helpful for the person who's going to use this application, and accordingly you can design the logic, because now the foundation is already in place. Right, so that's it from my side for this video. If you have any feedback or suggestion, please feel to put that into the comment section. If you are using any agentic AI for any purpose, share your idea what actually you are building, so that we can also understand how we are utilizing the power of large language model, which is enormous in potential. I know one person cannot even understand what kind of potential these large language models are having. And I am really impressed because in last few months, I have built a lot of application without even required any team members, right? So again, thanks for watching this. And one more request which I have, if you really like this video, give a thumbs up, hit a notification bell so that you will just get all the future video whenever it got published. And if you haven't subscribed for my channel, please consider to subscribe my channel as well. And as always, thanks for watching this. Stay healthy and keep learning new things.